Hi, this is Mr. Mon. I'm going to talk about investigation 4.5, investigating faults with models. And our focus question today is, what happens when you put a force on a fault? A little review from investigation 4.4 part B. We're going to look at question 19 and answer the following in our notebooks. See how we answered and compare those to your partner. So we're talking about the landforms that were created, when plates collided, when plates separated, and things like that. And we're going to go to our objective page and add down what landforms are found at each type of boundary. As we move on to investigation 4.5, we're going to construct an explanation for how geological processes and have shaped the Earth in the past and will continue to do so in the future. Number one here talks about the last two investigations. We explored the stress and movement that can cause changes on Earth's surface. Today we're going to be applying a force to that in a model. So you're going to think about what you've learned about brittle and ductile objects and answer the following questions in your notebook: what ductile rock is, locked layers, a tendency to rock fractures. And then we're going to be looking at the fault laboratory, which looks like off to the right. You're going to be having a couple sliding blocks, some friction, fault lines, and then a spring scale. So as you use figure 415 to set up your fault laboratory, check that you've carefully placed the place and you're using Velcro facing the fault. This should be set up for you today, but in case it isn't. And then experiment freely with the unfixed blocks. Look at how the block moves when it pushes or pulls. Try moving the block, and then place some houses, or in other words, some plastic centimeter cubes on the blocks, and pull again and record your observations. Big thing to do today is read earthquake and faults in your notebook, and as a group, you should think about the answers you find. Earthquakes, faults, San Andreas Fault in California. Together with your group, you can design an investigation that uses the fault laboratory to determine the following things. Determines how energy builds up during a plate movement and is released during an earthquake. So a lot of what we're looking today is how energy is built up and then released. You need to define your variables and then how you're going to measure and your data points. Your teacher will ask some groups to talk about this, and then we're going to let you go through your procedures. You're going to work with your group to carry this out, and then you discuss the results with your group and fill out sheet 4.5, investigating faults with models. You discuss the questions with your group. Make sure you're answering question number 13. And then you're going to create a conclusion in your science notebook explaining how rock elasticity contributes to energy being built up during plate movements. So you have steps 1 through 14 today. Make sure you're reading Earthquakes and Faults textbook 111 to 114. At this point, you should be finishing all your vocabulary for lesson 4. And then hopefully your teacher is going to place this video. It's from Bozeman Science, and it gives you a giant overview of everything you need to know about plate tectonics. Have a great day, Cardinals, and please let your teacher know if you have any questions.